Hey, good day everyone. Today I want us to look at the gas laws, but today we will be concentrating on Boyle's law, Charles' law, and the general gas equation. Maybe in our next video we will look at Gay-Lussac's pressure law, the ideal gas equation, and maybe Dalton's law of partial pressure. But today we will concentrate on the Boyle's, the Charles, and the general gas equation. But before anything, let's look at the conversions. Temperatures can be measured in Kelvin or Celsius centigrade. And you can convert a temperature, let's say 2 degrees Celsius to Kelvin using this formula. This 273 is a constant. It is the standard temperature. So let's say we should convert 2 degrees Celsius to Kelvin. We will have Kelvin equals to 2 plus 273, which is 275 K. Are you getting me? Or let's convert minus 29 degrees Celsius to Kelvin. Kelvin equals minus 29 degrees Celsius plus 273, which is now around 244 Kelvin. I follow you. Then you can also convert Kelvin to Celsius using this formula. Make this Celsius subject of the equation. So we now have C Celsius equals K minus 273. I follow you. So Celsius, if you want to convert this now, this Celsius to this, you can convert this to 244 degrees Kelvin to Celsius. Okay, let's say convert 30 degrees Kelvin to Celsius. So the Celsius set will now be 30 minus 273. The Celsius will now be equal to equal to 243 degrees Celsius. Actually, this is the formula. You want to convert. This is the formula for converting Kelvin to Celsius. No, this one. For converting Celsius. So for converting Kelvin to Celsius, and this formula is used for converting Celsius to Kelvin. Just replace the Celsius here and add 273. It will be converted to Kelvin. Hope we are following. Now, let's talk about STP. Mostly in the gas laws, we hear STP. STP means standard temperature and pressure. So that temperature and pressure, and at STP the temperature is 273 degrees Kelvin. 270 degrees Celsius, which is, if you convert it to Celsius, you will have 0 degrees Celsius. 273 or 0 degrees Celsius. And at STP, our pressure is 760 mmHg. which is equal to atmosphere. 1 atmosphere. Just remember that 760 mmHg represents 1 atmosphere. Hope you are following standard temperature and pressure. Let's continue. Let's go to Boyle's law. Robert Boyle is his full name. Boyle's law. The Boyle's law says that the volume of a given mass of gas is inversely proportional to the pressure, given that the temperature remains constant. Okay, so this is the mathematical representation of that law. V is inverse. Whenever you have inverse, it's inversely proportional to pressure. So we now have when the temperature is now constant, while volume is inversely proportional to the pressure at constant temperature. So we now have V equals to, we now have the constant. So the constant is now equals to multiply. We now have equals to Vp. So in the real sense of it, the Boyle's law is now given as V1P1 equals V2P2. For calculations, it is given like this. So this is the mathematical representation of the Boyle's law. Then sometimes you see the graph. We said that the volume is inversely proportional to the pressure. So that means when the pressure increases, the volume will increase. When the volume increases, the pressure will decrease, and so on. So usually this is the graph for this law. Sometimes in your exam you see something like that and they ask you which law has this graph. So you know it's Boyle's law. So when the volume is decreasing this way, the volume is decreasing upwards while the pressure is increasing. Can you see that? As this one is decreasing, this one is increasing. As this one is decreasing, this one is increasing. Can you see that? So this is the graph for Boyle's law. Now, let's solve one question on Boyle's law. So let's say we have 375 cm cube of a gas has a pressure of 700. That's a pressure. No, let's take it like this. 340 cm of a gas has a pressure of 700 and has a pressure of 800 mm. Mind you, these are the units of pressure. This is the unit of cm cube. It's the unit for volume. In mathematics, you should have known that. So find its volume. If the pressure decreases to that is when if the pressure decreases to 750 mm. So using the mathematical representation of the Boyle's law, we have V1 P1 equals to V2 P2. So in this question, the first volume you have there is 340 cm3. V1, which is now 340. P1, the first pressure is P1 is 800. V2 is unknown. That's what we are looking for. V2 is unknown. Then P2 is 750. So using this formula, we have this formula. We have 340 times 800 equals V2 times 750. So we now have 340 times 800. 340 times. We now have 340 times 800. Equals 750 V2. So we now make V the subject of the formula. V2 is now equals to, just multiply this by yourself, or let's take long multiplication, 340 800 0 0 0 0 0 0 0. So now V2 is now V2 is now 272,000 divided by 750, which will now give us 3662 point I believe you can see that. So the new volume is now 362.6 cm3. So we'll just be looking at one more question for clarity's sake, but you get your question and send it to me, the number I'll write at the end of this lesson. Send it to that number and you get your answer. This doesn't mean that you can't see more difficult questions than this. You can see that, but I just use this question to show you what it means to solve questions under Boyle's law. And let's look at Charles' law. Charles' law says that the volume of a given mass of gas is directly proportional to the temperature, provided that the pressure remains constant. So the mathematical representation is the volume is directly proportional to the temperature at constant pressure. So now this is the constant. So what to make the constant there? The subject of the equation. V over T. So from this now, just like we did before, the formula of the for Charles law now is V. This doesn't mean that you can't solve it like this or using this, but for more clarity, let's use this one. V1 over T1 equals V2 over T2. This is just variation in mathematics. In our next video, I'll be dropping a video on variation. It has to do with this mathematics. So let me give you a graph on Charles' law. The graph on Charles' law looks like this. It looks like this. So it means when the volume is decreasing, when the volume is decreasing, the temperature is decreasing at the same time. And you see that when the temperature is decreasing, the volume is decreasing also. That's what we meant by is directly proportional. They are directly proportional. So you might see questions like this, and they'll draw the graph in your exams and ask you to show which law has this graph. Just remember it's Charles' law. So let's get a question on that, on Charles' law. At 19 degrees Celsius, is a sample of hydrogen gas occupies 120 cm3. What will the gas what will be the volume of the gas what will be the volume of the gas at 90 degrees Celsius if the pressure remains constant? So yeah, from this question you know it's Charles' law. So using this formula, so it has to do with volume and temperature. Charles' law has to do with volume and temperature. So from this question, our first temperature is T1 is equal to 19 degrees Celsius. But mind this, you can't use this 19 to solve. You have to take it to the standard temperature. So you have to do that by adding 273 to it. It will now be 273 plus 19 will give you 292. Okay. So this is your T1. So V1, the first volume we have there is 120 cm3. So T2 is 90. T2 is 90 degrees Celsius. Take it to Kelvin by adding 273. So we now have 263K. No, we have 363 Kelvin, yeah. So V2 is what we are looking for. So using that formula, V1 is 120, T1 is 290, V2 is what we are looking for, T2 is 363. So when we cross multiply this, we now have 292 V2 equals 120 times 363. So making V the solid of the formula, we do this 292 over 292. This will cancel out. We now have V2 equals 120 times 363. Can you see that? So 363 times 120. Let's use long multiplication. So we now have 0. So V2 is equal to 37560 over 292. So V2 is equal to 149.12 cm cube. So from the question you can see as the temperature increased, the volume increased also. That's what's transfer. That's all about transfer. Then let's look at the general gas law. General gas law just has to do with the combination of the Charles law and Boyle's law. So Boyle's law is V equals to Charles law is V is proportional to E. Charles law is directly proportional to T. So combination of these two now will be V equals 1 over P. V equals T. So we want to join these two equations. So we now have take V. V is now equals to 1 over P times T. So we now have V equals T. P. So the formula for this equation is now V1. So the formula for this equation will now be V1 equals T1 over P1. No. Let's come like this. V equals 1 over P times T. So let's put the constant here. We now have V equals K T over P. So cross multiply. K T equals V P. Dividing through, we We have K equals V P over T. So from here now, the formula for that is the formula for the general gas equation is now V1 P1 over T1 equals V2 P2 over T2. No one will ask you how to derive this. I don't think anyone will ask you how to derive that, but once you see that, just do it just like I did it. The most important thing is just to memorize the formula to solve it. So just write it down like that. Let's look at the question under this. A given mass of gas occupies 850 cm3 at 320 K and 0.92 times 10 raised to the power 5 nm. Mind you, this nm is also a unit of measuring pressure. 1 atmosphere is equal to 760 mmHg and equals to 101,325 nm. So let's look at this pressure. Calculate the volume at STP. Most times the questions under the general gas law always carries STP in the question. So using this one, our first volume is 850 times our first pressure is 0.92 times 10 raised to the power 5 over our first temperature is 320. So at STP, whenever you have here at STP, you can see that the quantities given to us here are not complete. So at STP means you have to bring in those values you have at STP. STP means standard temperature and pressure. So the standard temperature is 273 and standard pressure is 760 mmHg. So the second volume you have here should be 850 at 320 degrees Kelvin. Calculate the volume at STP. So the volume is what you are looking for. V2 is unknown times the pressure. Look at this. The unit that this number carries is mmHg, while the one in the question has nm. Those are both units of pressure. But converting this 760 mmHg, which is equal to 1 atmosphere, is also equal to this 101,325 mmHg. No, converting into this, it will not have this value. So I didn't show you how I got this, but if you convert this to this value, it will give you this. We'll look at that later. So we now have 1, 0, 1, 3, 2, 5, all over. The temperature is now 270, which is the standard temperature. So if you work this out, I can't work this out for you now. Just find the calculator, do it just like I did the other ones. Just like I did the other ones. Just do it like the others, and you'll get your answer. So if you have any questions or any problem or any difficulty in this, just message this number. Mind you, on WhatsApp only. On WhatsApp. For your questions, you drop it on WhatsApp. Solve this, remember to solve it. And make sure you got the answer. Bring your difficult questions because it mustn't be this question, this simple in your exams. Just make sure you do further study and make sure you understand everything about it. Ask your questions on this number. So, thank you. This is all we have for today. See you next time.